This is Edible Materials Lab.
Edible Materials Lab.
This is Edible Materials Lab.
This is Edible Materials Lab. The idea for Edible Materials Lab really came from some of the initial material studies that I conducted through my research that were related to the exploration of digital technologies and their roles in fabrication. I'm Igor Siddiqui. I'm an assistant professor at the University of Texas at Austin School of Architecture.
So access to physical samples is really important for the designers that come visit our material library. It gives them a chance to have a really tactile experience with the materials, to see what they're working with and what they want to specify in either student projects or in real building projects. Hi, I'm Jen Wong. I'm the director of the Materials Lab. The Materials Lab is a resource center at the School of Architecture. We house a vast collection of over 27,000 building materials.
Digital technologies have, over the past couple of decades, allowed designers to increase the degree of customization, and so it made sense that we would start looking at the customization of materials in new ways.
There's a story behind every material, so there's kind of the scene quality of it, which is all of those tactile things that people have access to when they visit the collection. But there's also, importantly, an unseen aspect to every material. Everything has a story behind it, where the raw material was extracted from, how it was collected, how the material was manufactured, how a product was distributed, who made it. Those stories are just as important, in some cases more important than the aesthetic or the tactile quality of the material.
Pedagogically, these stories about where materials come from, how they are made, and how they might be applied are really important for students to understand, because it takes us from this idea that we only use existing materials and we apply them to design problems, to this new paradigm where materials are actually designed. And so this idea of made from scratch materials is a new reality for designers that clearly resonates so directly with food.
Plugged in, polarized, fist raised in anger, staring down, don't meet the eyes. Everyone's a stranger, 1,000 tunes ringing in my ear, no time for conversation. 1,000 channels wired to my brain, no thought, just sensation. Don't look at me, can't you see? I don't wanna talk to you. I'm plugged into the world, I'm wired but disconnected. Wired but disconnected.
The agricultural revolution marked a change in human history about 8,000 years ago. Humans went from hunter-gatherer lifestyles to forming much more dense populations and settlements based on farming.
This focus on farming allowed for larger, denser populations because mothers could now care for more than one child at a time. It also led to the creation of unique and specialized labor forces within this community.
Within the past 25 years in the U.S., cropland has decreased by 76 million acres, while developed land has increased by 36 million acres.
The increase in urbanization and growing urban fringe has led to the development of new and innovative ideas. Vertical gardens, rooftop gardens, and urban farms are all possible solutions to help feed the future populations of the United States.
When people hear edible architecture, they might think of gingerbread houses.
Yeah, or Willy Wonka's chocolate factory.
Or maybe even Candyland.
Yeah.
But food in society, the way that we think of food and culture, hasn't always been child's play.
In fact, as food has become more readily available, our association with its meaning has moved from moral concerns to flights of fancy.
And as technology has improved, we've started thinking of food as a material in an entirely different way.
Yeah, instead of chocolate rivers and ice cream castles.
So the Edible Materials Lab is exploring ways that non-toxic materials like bioplastics and gums or salt, or growing materials like mycelium from mushrooms or bacterial cellulose, or even waste products can be used again in innovative and compelling and responsible fashion.
Sure, and here we're looking at the architectural implications of those things and how they can have an impact on a greater scale, like addressing issues of human consumption or alleviating stresses on resources and other ways they can affect our cultural environment.
This idea that architecture is edible is a kind of hyperbolic framework that is allowing us to look at reality in a new, enriched way.
So the problem with human consumption has a lot to do with the awareness of each individual. People thinking, oh, well, I'm only one person, my impact doesn't matter that much in the grand scheme of things. So awareness and education about how much each individual consumes is part of the problem.
An idea of just one person's impact and how big it can actually be. During one person's childhood, they use about 3,796 diapers. But a lot of people don't actually visualize the origins or the energy that it takes to make that one product. And so those 3,796 diapers are actually comprised of 1,898 pints of crude oil, 715 pounds of plastic, and 4.5 trees. Human consumption is affecting our world's resources. And the wealthiest 20% of the world makes up 76.6% of the consumption.
The food industry uses 10% of the energy budget in the United States, compared to 48, close to 50% of the energy budget that goes to the building industry. For every calorie of beef that's produced, anywhere from 40 to 85 calories in human energy expended, in fossil fuels burned, and transportation energy is consumed to produce it. It's not sustainable. We're putting more energy burned in than we're getting out. Grains and other plants are much more efficient. We can produce 31 million kilocalories per hectare per year of corn in the United States. We produce 12 million tons of grain every year, and 10 of those 12 million gets fed to livestock. Only 2 million is available for human consumption. Clearly, the scales are massively tipped towards the less efficient food source here. Shifting the diet away from eating more meat, which we don't necessarily need for as much of as we're using, we can shift the building sector's diet away from inefficient Portland cement when it's not needed.
In each step of processing either a food or a material, there are small byproducts and waste products that occur at each level, and these mostly happen in the stages of refining or adding additives, or even just transporting a final product. Plastic, being a heavily refined and processed building material, doesn't have that much leeway with being reused. After one usage, the compound starts to deteriorate, and therefore it doesn't have a long lifespan. That's why it's looked down upon at an environmental standpoint.
Likewise, with the food and materials industry, there are a large number of byproducts that not only come from the food being raised itself, but from the packaging and what is wasted after the food has been consumed by its end user. So learning to take advantage of and disposing of our food products in an efficient way has become a really important thing for food and materials industries to consider.
A renewable resource is an organic natural resource that can replenish itself within a short enough time span compared to its usage. Generally, if it can replenish itself within our time span, then it's a renewable resource. There's also a further category of renewable resources called rapidly renewable resources, and these are resources that have a harvest cycle of less than 10 years, like bamboo or pork. This is why the materials we're working with, like agar, starch, and gelatin, are really exciting because they're resources that have a shorter renewable lifespan.
When we talk about the waste management industry and some of the issues surrounding it, what comes to mind are some of the different methods that the industry uses to manage the waste that we produce. We need to ask, are the current methods that are being used efficient for the long run? So for example, landfills are it's an old method of managing waste, and that problem, it has to do with the amount of land space that's being used for landfilling.
Another method being used is incineration, and incineration is simply the process of burning materials instead of having them piled up in landfills. And what's great about this method is that it has reduced the volume of waste found in landfills. However, it does release chemical gases during the process, and that becomes harmful to our environment.
In architecture, we tend to celebrate permanence and monumentality. However, when faced with issues of sustainability, waste, and consumption, we need to shift our focus towards material temporality.
Not all buildings have to be thought of permanently. We invest a lot of energy and resources into temporary structures such as single-use sports stadiums, market spaces, and exhibition spaces.
Edible materials provides a lens through which we can look at design without a predisposition towards permanence.
Our custom is to use materials that are readily available and well understood, but if we shift our focus towards bioplastics and highly customizable materials, we're able to bypass industrial processes that are resource and energy intensive.